Okay, so for this particular problem, a small body is thrown at an angle to the horizontal with initial velocity v naught. Okay, v naught is the vector. Neglecting the air drag, find the displacement of the body as a function of time, which is represented by r of t, and the mean velocity vector v averaged over the first t seconds and over the total time of motion. Fine. Okay, so first of all, the first part is quite simple. So it basically asks you the displacement vector of the body, right? So we already know that when basically the acceleration is basically the acceleration due to gravity. So this is your w is basically acceleration due to gravity, w vector, and that we'll represent it by the g vector, right. Now uh, we know that in one dimension, in single dimension, your displacement, if I represent displacement by r, let's say for a single dimension, let's say only consider in the x-axis, right? Along x-axis, my x components only if I take, then for a single dimension I can write that rx is equal to the initial velocity in the x direction, which is, let's say, v naught x, right, into time t plus half acceleration in the x direction wx t square. Similarly, along y axis you'll have a similar formula. It will be ry is equal to v naught y times t plus half wy t square. Okay, now we know that r, so of course r I'm writing, it basically means r of t, right? This is nothing but rx I cap plus ry j cap. So then r vector is nothing but, what is rx? So rx is this, so v naught x into t plus half wx t square I cap plus v naught y times t plus half wy t square j cap. Okay, so if we take the first terms in each like component, right, then what does it become? Becomes t times v naught x, or rather just a second, sorry, becomes v naught x I cap plus v naught y j cap times t, right, plus half, okay, the second terms again if we group, half into wx I cap plus wy j cap times t square. Okay, so this is basically the velocity vector and this is the acceleration vector, right? So this becomes v naught times, so this becomes v naught times t plus half. Now the acceleration is represented over here as g, so I'll just replace this term by g. The basically the g vector, right, half g times, yeah, of course, yeah, t square. So this is your r as a function of t. So this, the first part is done, simple. The second part is the mean velocity vector v averaged over the first t seconds, first of all. Okay, so in the b part, you know that the average velocity vector v is nothing but the displacement in the, of course, after a time t, so average velocity is nothing but the change in the displacement vector divided by the change in time. So what this means is r at t minus r at 0 divided by t minus 0, right? Now at 0 it is at, we are considering that it is at origin, so anyways, yeah, so this becomes basically, so basically it's nothing but r of t, rt, because r0 is 0. If you substitute here it becomes 0 anyway, so 0 rt by t, so just it's this equation just divided by t, that's it. So it becomes v naught plus g times t by 2, right? So this becomes your average velocity vector after time t. But the next thing that they're asking is over the total time of motion. Okay, so we have to find out what is the total time of motion, and we have to substitute in this equation. So what is the total time of motion? Okay, now in the problem statement they have they say that it is thrown at an angle to the horizontal. Okay, fine. So in this part where we need to find out the time of motion, so essentially what we need to see is, like, let's say the particle was thrown at an angle at this point, okay, right, like this, and the thing is that it should, so for the basically for the particle to complete or as they say in the question, the total time of motion basically we would be considered as when it comes back to the same level again, right? Okay, so the rough trajectory would be something like this. Okay, this is a rough trajectory. So basically we can see that in the y direction your displacement sy, let's say we call it as sy, let's say it is 0, right? Okay, so this is how we'll get the time of motion. Okay, so this s is equal to ut plus half at square, we already know. So in the y direction, so the initial velocity is v naught y, I'll call it v naught y, the y component of v naught times t, right, plus half. So see, y, this is positive y direction, okay, but g is acting this way, so acceleration is basically minus g, okay, right, because we are considering positive y direction, which is in the opposite direction to that of the gravity. Half into minus g into t square. Okay, so this means like either t equal to 0, right, or obviously at t equal to 0 displacement is 0, that is like, I mean, that is not the solution what we are looking for, or v naught y minus gt by 2 equal to 0, right? Okay, so this means your time is equal to 2 v naught y by g, right? This is your time of motion. Now, okay, what do we have, or in what terms can we write? We are allowed to write in terms of the v naught vector and the g vector. Okay, so that's what we are allowed to write. Now this is a side point which will help us to get to how to write in terms of the vectors. Just write it in red because it's important, this part is important. So see, v naught y, okay, let's consider it this way, that if we want to find out the component of any vector along a particular direction, right, so we multiply it with the dot product of a unit vector. We basically take the dot product of that vector with an unit vector in that direction. in which we want the component. So for instance, in this case, v naught y, right, v naught y would be simply v multiplied by, I mean, dot product with j cap. That's what it would be, right? Okay. And we also know that the g vector, right, since g is in the opposite direction of the y, is basically minus g j cap. Okay, so this means j cap can also be written as minus g by g, right? You can write this minus g vector by g. So this means we can write v naught y as, we can substitute this over here, so that will give us minus, okay, minus of course this v naught, yeah, so minus v naught dot product with g, right, divided by g. So this is your v naught y. Now this will substitute here. Okay, so that will give me t is equal to 2 by g times v naught y. So basically it becomes 2 by g times minus, of course, minus v naught v naught vector g vector by g. Okay, and what do we need? Okay, we need this, we need v naught plus gt by 2. Okay, so v at the, I mean, for the total, let's for the total time of motion, let's say it is vt. Let's say I'm just denoting with that. All right, so this becomes v naught plus gt by 2, right? So v naught, okay, v naught plus, now over here what will happen is g by 2 times t, right? So t is 2 times minus v naught g, right, plus g by g square, right? 2 cancels out, right? Okay, so what does this give me? This gives me v naught vector, right, minus sign you can take it out, okay, minus g vector, right, times v naught dot g, which is a scalar, of course, because it's a dot product of two vectors is a scalar. So minus g times v naught dot product with g divided by the square of the magnitude of g. Okay, so this was basically a manipulation of like how we can use dot product. It's not a very difficult manipulation, but yeah, it's always better if you understand this in terms of dot products. It's very easy to understand, right? So the main concept over here is the component. I'll again write the main concept, or rather the concept that sort of is a difficult one, is the concept is easy, but it is used for solving a sort of a difficult problem over here. So the component of a vector in a particular direction is the dot product of that vector with the unit vector in said direction. This is the main concept that is being sort of used. because the first two parts are pretty easy, pretty trivial, but the third part, or basically the second part of the second part, however you may call it, that is the average velocity vector for the whole time of motion. So writing the time in terms of these vectors of the initial velocity vector and the acceleration vector is might seem a bit challenging, but if you get this main concept, then it's very easy to handle. So yeah, that's that. Thank you.